This section seems to be covered the chain rule. The chain rule, there's different methods to look at it. Basically, you work from the outside in. If you have a function built inside of another function, the technical term is composite. You have a function that you put inside another function. What you do is you take the derivative of the outside, and then you take the derivative inside, from the outside in. The example they gave us, for example, number 1 says they give you these two functions. Y is equal to 8u plus 1, and then u is equal to 1/4 x to the 8th. The way the book does it, it uses the technical language for it. What I suggest makes it a little bit simpler. You put the u inside the y first. So this becomes y is equal to 8 1/4 x8, like that, plus 1. Now if you want to take the derivative with respect to x, and that's what they're looking for. They're looking for dy dx. So you do it, take the outside derivative, and then take the inside derivative and multiply them together. So dy dx would be the derivative of the outside. What's the derivative of the outside? Well, the outside, well, actually, you can actually do it all at once in this case because it's simpler. If you plug it in, this becomes, this becomes 2 x8 plus 1. So the derivative of this is you bring the 8 down, multiply it times the 2. This becomes 16x. You take away 1 from 8, that becomes 7. And the 1 goes to 0. So the derivative dy dx is that, 16x to the 7. This one was simpler. The way they describe it sometimes in the book, a little bit more complicated. This one, when I plugged it back in, I could actually just simplify it. In some cases, you can't do it that way. But I suggest you still plug in the number. Just plug in the function into the other function and then work from there. Let me give you another example. For number 2, change this background. For number 2, they give us function y equals sine of u, and then they give us u to be equal 6x minus 1. And that's number 2. And they ask you for dy dx. Again, my suggestion, plug it in. Plug in u into the u. So this becomes y is equal to sine of 6x minus 1. This one, you can't simplify. This one you have to actually do the derivative of sine and then do the derivative of 6x minus 1. The derivative of sine is cosine. Notice that you leave the inside the same. Then you multiply this by the derivative of the inside. The derivative of the inside is 6, because the derivative of negative 1 is 0. The derivative of x is 1, so all we're left with is 6, so it's times 6. Rewriting it, dy dx equals cosine 6, one second. Equals 6 times cosine 6x minus 1. That's the derivative. Give you another one. Number 3. The 3 asks for to give you y is equal to the tangent of u, and they say that u is equal to 13x. Verify that that's right, but I think that's right. 13x minus 1. I plug it in. Y equals tangent of 13x minus 1. What do? I take the derivative of the outside, and then times the derivative of the inside. The derivative of the outside is secant squared 13x minus 1 What's the derivative of 13x minus 1? 13. So we multiply that by 13. So this becomes dy dx is equal to 13 times secant squared 13x minus 1. That's our derivative. Number 4. Says they give us kind of like a compound function. They basically give you a y. They give you y is equal to 3x plus 16. 3x plus 16 raised to the 6th power. It's already plugged in. They don't give you a u or anything. They say split it up into different u's and g's and whatever. But what I would do with this is take the outside derivative, which is just look at this as just one letter. And then this comes down, so dy dx would be 3x plus 16. Take 1 away from the 6, which becomes 5. Now take the times the derivative of the inside. What's the derivative of the inside? Well, 3, because that goes to 0. And 3x, the derivative of that is 3. Now we have a 3 on the outside, we have a 6 on the outside, so that becomes 18. 18, 3x plus 16 to the 5th power. And that is our dy dx. So number 5. Actually, for number 4, they actually ask you, they don't ask you for the derivative, they ask you for what would be your u and what would be your g of x. Anything, the u would be u of 6, that would be your u. F is a function of u. And our g of x is the inside, which is 3x plus 16. That'll be your g of x. So the answer for this one would be C. Number 5. Number 5, they ask you the same thing. They say, what's your f of u? And what is your g of x? And the function is y is equal to x squared over 4 plus 5x minus 4 over x. Now if we take the derivative of this monster, it's really bad, but they don't ask you to take the derivative. They just ask you to break it up into the 2 parts, the u and then the outside part and then the inside part. Well, the outside part is the one that's on the outside, and that's to the 5th power. So our f of u is going to be u to the 5th. And our g of x, our function as a function of x, is going to be the inside part, which is x squared over 4 plus 5x minus 4 over x. That's our inside part. Now if you wanted to put it like this, that's our outside and that's our inside. So the answer for this one would be B. Number 6, they actually ask you to ask you to find the derivative. This one, the derivative, the function they give you is this number 6. They give you y is equal to cosine and inside the parentheses cotangent of x. And they ask you to find dy dx. Now it's already a composite function. The outside function is cosine, the inside function is cotangent. So what we do is we take the derivative of the outside, multiplied times the derivative of the inside. Derivative of the outside, the derivative of cosine is negative sign. Now keep the inside the same. Because now we're going to multiply it times the derivative of the inside. The derivative of the inside is negative cosecant squared x. Now those derivatives for the trigonometric functions, you're going to have to just memorize. Sine, the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of tangent is whatever it is. Those you have to remember. There's no way around that one. So this, let's simplify this, make it look a little nicer. This is on the outside, that's on the outside, so these two negatives are going to become positive. Let's do it this way. Let's put cosecant squared of x times sine of cotangent of x. And that's our dy dx. Let's do another one, number 7. Number 7. Come on. Where's the page? Number 7. E to the negative 8x. Some students will get confused. Well, not confused. They just don't like that e thing. F of x is equal to e to the negative 8x. Same thing, you can look at it as e to the u, and then u being negative 8x. What is the derivative of e? E. E stays the same. So the dy dx for this one, the derivative of this, the outside, is just e to the negative 8x. It doesn't change. The instructions probably showed you why, but it doesn't change. Now you multiply times the derivative of this part. What's the derivative of negative 8x? 8. That's the negative 8. Negative 8. That's the derivative of negative 8x. So this becomes negative 8e to the negative 8x. And that's our dy dx. So number 8. Number 8 says, find dy dx of y is equal to negative 6 plus 7x. Some students forget what the square root means. Square root can be shown as a power. We can write it like this. Anytime you have a square root, it's actually anything that's raised to a half power. That's why it's called the square root. Now this you know how to do. The outside function is that raised to the half power. The inside function is this right here. So in a regular power, you bring this down. So our dy dx is you bring that down 1/2. You do the inside the same. Oops. And then you take away from that power. If you take away 1 from 1/2, what do you get? You get negative 1/2. Then you multiply it by the derivative of the inside. What's the derivative of the inside? Well, the derivative of the inside is 7, because this goes to 0. The derivative of 7x is just x, because x to the 1 power, you take away the 1, becomes 0, that becomes a 1, so this is 7. So we have here, multiply all the way across, 7 over 2, 7 over 2, times everything on the inside. I'm going to flip these, I don't like the way it looks, but you can keep it the same, really. Minus 6, and that's still raised to the negative 1/2 power. And that's our dy dx. Number 9. Number 9, they give you a monster. They give you S is equal to 8, 5 pi cosine of 5t plus 8 over 9 pi sine of 9t. And I want you to find ds dt. Derivative of s with respect to t. Well, the same thing, because we're adding these two, I can take the derivative of this, and I can take the derivative of that, and just add them together, because they're separate. They're not separate functions, but they're separate parts of the same function. So let's look at this. What is the derivative of this part here? Well, the only function that we have here is cosine. The derivative of cosine, this is just the number multiplied, so that stays the same. It's like a number in front of a function. So this stays the same. The derivative of cosine is negative sine. We keep that the same in here. Now we multiply it times the derivative of the inside being 5t. What's the derivative of 5t? 5. And now we did that. That's the derivative of this part here. Now we're going to add the derivative of this. The only function we have here is sine. This stays the same. It's like a number in front of a function, so that doesn't change because we're multiplying. Let me erase that real quick. Before 8. Derivative of sine is cosine. We keep this the same. What is the derivative of 9t? 9. The derivative of 9t is 9. So we multiply across here. We get 8 times 5 over 5 pi negative sine 5t like that, plus multiply across 9 times 8 over 9 pi cosine of 9t. Notice what happens to the 5 on the top and 5 on the bottom, 9 on the top and on the bottom. Don't you love it when it comes out like that? No? Okay. It's a negative sine 5t multiplied times an 8, so I can take that little negative and put it in the front. I'm going to do a negative 8 times sine 5t plus 8 times cosine of 9t. And that, my friends, is the derivative ds dt. Last one, number 10. Okay. Where's it? Did I do it right? Yeah, I think this is what they gave us. They gave us number 10 on the derivative of cosecant x minus cotangent x, that raised to the negative 1 power, and that's for y. And that's for y equals x. And they asked for dy dx. Take the derivative of the outside being in the parentheses, everything else on the inside is just, it's within it, to work our way from outside to inside. The derivative of the outside is negative 1. We leave everything else the same. If you take away 1 from negative 1, what do you get? Negative 2. Now we multiply that times the derivative of the inside. The inside, what is the derivative of cosecant? Anybody? Anybody? The derivative of cosecant is negative cosecant x times cotangent of x. Again, something you have to memorize. And the derivative plus the derivative, minus the derivative of cotangent x. The derivative of cotangent x is negative cosecant x. Cosecant x squared, actually. Cosecant squared x. That's the derivative of cotangent. Because that's the derivative of cotangent, notice these two negatives. They go positive. I'm going to rewrite this a little bit simpler method, but notice what the question asks. The question asks, actually that's what it asks for, the derivative. So I'm going to simplify this a little bit. I can't distribute this negative on the outside because it's raised to a power. In here I can simplify it. I'm going to keep this the same. In here I can simplify it by, this becomes positive, so I'm going to put it over here. I'm going to put cosecant squared x, it's positive, minus cosecant x cotangent x. Parentheses. And that is dy dx. That's all she wrote.